Now this all seems to have led up to the discussion about the database management systems, DBMS. That's system software that's designed to organize, control, and use data as needed by applications and programs. The primary function of the DBMS includes the reduce of data redundancy. Now, I know it sounds funny, you're saying the goal is to make less data. Well, the goal is to not repeat data. We also want to be able to see that we can get decreased access time and basic security. Now, your DBMS data is going to be organized into basic data elements, like a field that's defined by a data dictionary. A DBMS can also control user access at many different levels. Some of the advantages of the DBMS, of course, is data independence for applications. Right? We're storing data, and it's just that. It's raw data. Any application you write that has access can use it. Easy support of flexibility in meeting a changing data requirements. Transaction processing efficiency. Now, that's important, right? Because a transaction means a change in data has to occur 100% or not at all, and we want that to be efficient. Again, as I said, we want to reduce data redundancy. Maximization of your data consistency. Enforcement of your data or programming standards. Enforcement of your data security. And having integrity checks in how we store the data. Well, let me see if I can kind of illustrate some of these database management system concepts that we were just talking about. And I'm going to utilize, and you're going to see this discussion over and over, by the way, as we talk about things like normalization and some other things that we look at in the databases. But this is a table, and this table is going to be for the Department of Motor Vehicles. And these are going to be my drivers. Right? Now, the thing about drivers is that they have names and dates of birth and physical characteristics and addresses and date of expiration and all that sort of stuff. And so we look at those as fields, and the fields would be these columns that we use, whereas each row would be the record that we're talking about. And so, we'd have like a name of the driver, a column for the date of birth, a column for the physical characteristics, a column for the expiration. And well, you know what? We also probably need a column for the tickets that they get. Yeah, we got to keep track of that. Now, over here, we usually have something unique to identify them with, like a driver's license number. Now, so let's think about it. We've got this driver. We'll call it Ken. And date of birth, we'll just say old. And I'll leave off all the other stuff. And tickets. All right, so I got one, believe it or not, 74 in a 70, many years ago. I don't know what I did to make somebody mad, but I got one. Anyway, now, here's the question. I'll be driver license number 1. I get a new ticket. Now, what do I do? Well, I guess you could put me in again on a second row to get, and by the way, I didn't get another ticket, but let's say I really earned it. Let's say 75 and a 25. Okay? And so there's my next ticket. And then I'm on a roll. Let's say I got a parking ticket, so you have to put me in here again. And you see what I'm doing is I'm duplicating all this information over and over again in order to be able to put in the information about the ticket. So then people say, well, why don't we just add some more columns so we can have room for more tickets? Be careful, I'm almost beginning to make a discussion for data normalization, but I won't go too far with that. And so now we can have ticket 2, ticket 3, ticket 4. Okay, I'm good with that idea. That makes sense to me. So now I could just start filling these in. But so what did I do? I made room for 7 tickets. I hate to say this, but I know people who have gotten more than 7 tickets in one stop. I mean, that must have just really been a bad day for that person. And so now what I'm stuck with? I'm stuck with having to repeat data. Or I'm going to have to keep adding more columns to make room for all those possible tickets. But then there's this driver, right? Driver number 2. And I wish it was Ken again. We'll make it Dave. And we'll say Dave's young. And Dave's so young that he hasn't had a chance to get a ticket. So look at all this memory that we're wasting to store room for the potential of tickets. So what we're trying to do, as we said, is we're trying to reduce data replication or duplication. And we're trying to, be efficient with things like memory. And so now suddenly you're saying, well, then what's the solution? Well, the solution is for you to pay attention when I talk about data normalization. Because what we end up doing is using multiple tables and relating them to each other, creating a relational database. At least that would work for this little example of the Department of Motor Vehicles. And that would eliminate both of these problems. Or not eliminate, it would give me, right, through a relational database, a reduction of duplicated traffic. It'll be more efficient in the memory. Now, the next thing I have to worry about is you've got a program on your computer, and you need to get the access to this information. So you could just make a direct connection right here to the actual database. But, you know, all you're supposed to do is read the data, and or maybe you're, you know, allowed to put the data in. That's great. But you could make mistakes, right? You could do bad entries. And so what we often do is if you just want to read data, and I'm going to use a Microsoft symbol of a pair of glasses, kind of look like those Harry Potter glasses, they create these objects called views. And the views link to the table, and so the program would just grab a hold of that view, which would allow it to be, right, it's now a read-only copy that they get, and they can't alter the information. If they want to make a change, now I can't draw this picture as well as a little Microsoft icon. Probably some of you think it looks like one of those mines. It's a cog, right, or a sprocket. We call those stored procedures. They like to call them sprocs. If I want to make a change, I'm going to go and connect to this sproc stored procedure, and it has all of the verification and integrity checking and other code, so it can make the change in an appropriate manner and make sure that I put the right information in the right spot. And they put these in as methods of protecting data, obviously to maintain the integrity of the data as well. And they do this so that we purposely are having a database management system that is trying to make sure that we are doing everything we can to preserve our information and our data. Now, when we take a look at the architecture of the DBMS, we see all these objects, and you heard me talk about some of them, like tables, the fields, the rows, the records, views, all these things. These objects are things that we create into the database management system, but what makes that object different than another? And that's by its definition. And the definition is what's stored in what's called metadata. I like to tell people that metadata is the information about the information. So metadata is the way, if I say I want a new table, metadata says, okay, here's what a table looks like. You'll fill it in with all your information, but here's what it looks like. I'll build that for you. So it's got the data elements, physical fields, the files, the creation of data relationships, queries. They're all a part of definitions found in metadata. Now there's three types of metadata. You have the conceptual schema, the external schema, and the internal schema. Now, as I said, within each level, there's a data definition language, a DDL component, that's used to create the schema's representation of interpreting and responding to a user request. Now, there's a data dictionary, or sometimes called a directory system, that defines and stores the source and object forms of all data definitions for all schema types. Now, the DDDS provides the following capabilities. It has the DDL processor, which allows the creation or modification of data definitions. A validation method to be able to basically validate the definition provided for the integrity of the metadata. Prevention of unauthorized access or manipulation. And the interrogation and reporting facilities that allow the database administrator to be able to inquire on the data definition.